So today I want to talk about monostable multivibrators. So monostable multivibrators. So what is the function of monostable multivibrator is I will show you. Suppose this is a box that contains the circuit of monostable multivibrator, and we have our input. If at the input we give a trigger pulse by lowering the input by adding a switch, if we just give a trigger pulse, then the output will stay high for some time and then get low. It will get low automatically, and that is determined by the resistor and the capacitor network that we connected, that we set. If suppose the RC value is large, then you will get a large amount of time. The RC constant is low, then you will get a shorter duration of time. That means it will turn off after less time. So this time period T is determined by R and C. Okay, so you may think that this is the story over, but no, there is more to it. So there are two types of monostable multivibrators. One is retriggerable, and another one is non-retriggerable. So there are many ways of making a monostable multivibrators. I have these three methods which I use. You may know many of them, but I know only these three. So one is by using 555 IC. Another is by using operational amplifiers. The third one is by using transistors. So this one, by using transistors, it also uses the same logic as op-amp, but transistor is also a switching device, so we can connect a capacitor and resistor network to transistors. But yes, the output will be not much smoother. We'll have to use more transistors. So I have made that using transistors, but by using op-amp, it looks similar to that of timer IC 555. But still, it's different than what 555 has to offer. So 555, the output is non-retriggerable. The monostable multivibrator is non-retriggerable. But these two, when we make monostable multivibrator with these two, they are retriggerable. So what does that mean? If suppose this is the input and I give a pulse, so at this instant the output will stay high and then will get low at this point. But at this point, suddenly I give it a trigger pulse and the output has to add on. Means instead of getting low here, it will add the time again and will get low. So this operation here is retriggerable. But in timer IC 555, this doesn't happen. If we once trigger the circuit, if we trigger it again and again, so it doesn't matter. If you trigger it here, it will get low and will get low after the set time period, and then it will get low for the time duration, which is the interval between these two pulses. It will again get high and then get low. So there is a discontinuity between two pulses in timer IC 555. So this operation is non-retriggerable. So both of these are very useful. They are useful applications in many circuits. Means nothing is disadvantage. There's no disadvantages, only advantages. So also advantage, this is also advantage. So we can see at the simulation app, in my simulation app, that how this non-retriggerable function works. So let's get on to the simulation app. So this is every circuit app and I use it to create circuits. It shows same results as that of practical. It's a free app on Play Store. It's a very good application. So today I'm making so our circuit is made. I will turn on simulation. So before turning on the simulation, I just want to mark this input and output. So the output is blue and input is green. So I will start the simulation now. You can see the graph. So I will give a trigger pulse. You can see the output goes high and then goes low for 1 milliseconds. So what I want to tell here is that if you give a trigger pulse again and again, the output will get low after some time. So you can see that, look at the blue graph, you can see that the output goes low. No matter how many trigger pulse we send, the output will get low. By mistake this got marked, the switch got marked. So what we will do, stop the simulation and mark the switch and hit the play button again. And this also got marked. So this is a trigger pulse. So the output gets low after 1 milliseconds. No matter how many trigger pulses we pass. So this operation is the non-retriggerable function that is possible only in the timer IC555. And practical also it shows the same thing. Because of the internal construction of 555, it has got a set reset flip-flop. Because of that, this phenomena is seen. So let's check the other circuit, which is op-amp based monostable multivibrator. So this is a transistor based monostable multivibrator. I'd like to show you this too. When you trigger, the output gets high. You see the blue one is the output and it will get high for some time. But what happens when we give it a trigger again? See, the capacitor never gets time to charge, so the output will stay high. So in this, the trigger pulse, we give the trigger, the output stays high and gets low. But if we give the trigger pulse again and again, the output will stay high. So this monostable multivibrator has got its own application when we want the circuit to get re-triggered. That means suppose we want to convert AC into DC. If we have AC value, we are constantly giving AC supply, then we can get a DC stable output. This is the application of this circuit. So let's see the op-amp circuit which is similar to this. See the op-amp circuit. Monostable multivibrator using op-amp. So here also it's the same condition. In here the switching is done by the operational amplifier. So here, as you can see, the blue one is the input and green is the output. So if we trigger it, the output will stay high and then get low. The output will stay high and then get low. So if you trigger it again and again, the output will remain high because the capacitor will not get time to charge. So yes, this was the circuits of monostable multivibrator, and I hope you liked it and you learned something. I will give the link in the description for both my simulations, this one and another one. So thanks for watching.